In this particular lecture, we are going to discuss about identification of the failure position of the valve from the P&ID. So before going into this, just want to highlight the fact that control valve can fail due to the multiple reasons, right? It can be mechanical failure of the valve, it can be breakage of any of its parts, it can be also the failure of the power supply and failure of the driving force, which can be air or nitrogen in case of pneumatic valve, and it can be hydraulic oil in case of a hydraulic valve. So when this driving forces fail, the process designers had designed requirements suggest that valve moves to a certain predefined position so that the process can be saved from the undesired consequences, right? So that is the reason why the valve fill position is required. Now, this is a globe valve with spring and diaphragm on it. And as you can see from the pneumatic connection here, the two valves, pneumatic connection is slightly different. On one of the valve, you can see the connection of air from the top, and another valve you can see the air connection is from the bottom, right? As this is a spring and diaphragm valve, there is normally, if you deconstruct the valve in a simple way, there is a diaphragm and there is a spring. From the bottom of the spring, basically there is a stem, right? And stem is then further attached to the plug of the valve, and the plug is sitting on the seat, right? And this is the flow path. This is how the flow is going through. So when the plug comes down, there is a restriction to flow occurs when the plugs moves up. So when it is coming down, it is basically closing, and when it is moving up, it is basically opening. And the air, when the air is giving into it, what is happening? When air is giving, then it is compressing the spring, right? It is compressing the spring, putting the stem down and putting the plug down closer to the seat. So the flow will be less. So in this case, where there is a air is basically closing the valve. So this is called air to close, right? Now what will happen if air is not there, air is removed, or due to some situation, suppose this particular tubing got broken here, right? So when air is not there, so you can see this upper side, there is no pressure, right? The spring which is compressed now will try to get back to its original position. So spring will move upwards. This will cause the stem to move out upwards, plug to move upwards, causing the valve to open, right? So this particular valve is then fill open, right? You can also do the same thing for the right side valve. So there is a, again there is a diaphragm, on the below there is a spring, and from the spring there is a stem that is attached to it. Now at the bottom of the stem there is a plug, and plug is sitting on the, plug is actually plugging the seat, right? So, and this is the flow path. The flow is going through this particular path, right? Now, what will happen when now air in this case is from the bottom, right? So as the air increases, it overcomes the spring force and pulls the stem up, and this causes plug to further detach from the seat. So this is air is causing the valve to open. So this is air to open, right? Now, in this particular scenario, if air got cut out, what will happen? The spring will go back to its original position, which is downward, which will further push the stem downwards, and the plug will become much closer to the seat now, or almost get seated on the seat, right? So this will cause the valve to close. So this is how this is called fail close. Now, this phenomena should be depicted in the P&ID, or from the P&ID, people should understand that the valve is fail close or fail open. Now, what are the different P&ID symbols are? So this particular valve, as you can see, this is a fail open valve, right? The arrow is pointing upwards. In some other cases where there is no arrow pointer, the simple valve is shown, and on the side of the valve, FO is written. For fail closed valves, the arrow points downward, or the valve with symbol of FC. In case of the fail last valve, the arrow is pointing both ways, both upside and downside. Now, we have not talked about fail last here. Fail last phenomena normally you can see with the double acting actuator, where the actuator does not have a spring, rather it has a piston attached to it, and their air supply comes from the both ways, right? So in this case, what happens normally is when the so, and this is somehow attached to the valve, okay? This is very crude picture to it. But now air is here also, air is here also, right? So if the air is cut both sides, the piston will remain in this position, right? So this is basically called the fail last position, or FL. Sometimes it is also denoted as FL, right? But fail last, only saying fail last sometimes does not tell you the full story, because even your valve is just there is air is cut over the period of the time, what will happen due to the gravity or other phenomena, valve will move to a particular direction, right? So that's why normally it is said that not only fail last, with fail last you also mention whether the valve will go to fail drift close, or it will go to drift open. It is also denoted at DC or DU, right? But sometime with additional pneumatic accessories or additional accessories outside the valve is designed in such a way the valve will stay at a fixed position. It will not move. It, it is done by additional accessories, right? So in that case, you can call the valve fail last. In other normal situation, valve normally fails at the last position, but it slowly drifts into either close or open position. What I mean to say here is the valve can be designed in all three ways, either by the construction or design of the actuator itself, or you can add additional accessories to it to make a valve fail close, drift, fail last, drift close, and drift open. Now let's talk about three-way valves. So three-way valves, basically the fail action is given by the failure open path. So it can open either A to C way, or it can open in the B to C way, or it can open in the A to B way, right? So for example, for this particular valve, we have initially shown that A to C is the failure path. Similarly, for the four-way valve, the failure path can be A to D or B to C. So normally the two failure paths are shown for the case of the four-way valve, and for the case of the three-way valve, one failure path is shown. So hope you have understood the different failure symbols of the control valve, and this is very important because this is one area where there are lots of mistakes happen and the lots of contradiction happens between P&ID and other document. So have a closer look of the failure position of the valve in your P&ID.